Hello everyone, this is Anika Mishra and welcome to Scope Edification. So today we are going to study isomers. So what are isomers? Isomers are compounds having same molecular formula and different structural formula. Iso means same and meros means part. So isomers are compounds having same molecular formula but different structural formula, and this phenomena is known as isomerism. Now there are two types of isomerism: structural isomerism and stereoisomerism. So stereoisomerism is also called as space isomerism or geometrical isomerism. Now in structural isomerism there are three more parts: chain, position and functional. Let us understand this in detail. So chain isomerism. Let's see an example: N-Butane and isobutane. Here both have the same molecular formula, that is C4H10, but if you see the structure here, that is different. In N-Butane it is a straight chain and in isobutane it is a branched chain. We will study straight chain, branched chain in detail, but just understand the basic concept here, that in N-Butane it is a straight chain and isobutane is branched chain, that is different structure, but the molecular formula here is C4H10. Now position. So in position, functional group will be same, but position of functional group will be different. Let's see an example. So we have butene 1 and butene 2. So here the functional group is in the first carbon atom, double bond, but in the butene 2 the functional group is in the second carbon atom. So the structure here is different, but they have the same molecular formula. Now functional group. So in functional group, same molecular formula but different functional group. So let's see an example here. We have ethanol and dimethyl ether. So if you see, the molecular formula is C2H6O. Both have the same molecular formula, but in ethanol the functional group is OH and in dimethyl ether the functional group is O. That is, here the functional group is hydroxy and here it is ether. So this is functional group. Okay, so now we will study chain isomerism in detail. So chain isomerism has three parts, that is N-alkane, isoalkane and neoalkane. So N-alkane will have straight chain structure, isoalkane will have branched chain structure, and neoalkane will also have branched chain structure. Now these isomers arise because of the possibility of branching in carbon chain. So that can be straight chain or branched chain. So now we have an example here of C4H10, that is N-Butane. So but meaning 4 and ane meaning single bond. So we will draw 4 carbon atoms that have single bond, 1, 2, 3, 4. Okay. Now we have to satisfy the valency of carbon, that is 4. So as you can see here, this carbon atom already has one single bond with the other carbon atom. So it needs 3 more to get satisfied. So 1, 2, 3, 4, done. Same thing we will do here. So this carbon atom already has one single bond with the other carbon atom. It needs 3 more. So done. Now the second carbon atom has one bond here and one bond here, so it needs 2 more. So 1, 2, 3, 4. Same thing we will do with this one. So this carbon atom has one bond here and one bond here, so 2 more. So 1, 2, 3, 4. This is how we do it. So this is N-Butane, that is straight chain structure. This is how we form the structure of N-Butane. Now we have to form the structure of isobutane, that is branched chain structure. So in isobutane we have to take one carbon less, and in the second carbon there will be methyl group as substituent. So but meaning 4 and ane meaning single bond, but here we will take one carbon less, so we will draw 3. Done. Now the second carbon atom here will have methyl group as substituent. So methyl group, this is the second carbon atom. So methyl group is CH3 Okay, now we will satisfy the valency of carbon. So this carbon already has one single bond with the other carbon, so we need 3 more. So 1, 2, 3, 4. Now here this carbon has one bond with this carbon atom and one bond with this carbon atom and one bond with this carbon atom, meaning it already has 3 bonds here. So we need one more bond, so H, done. So 1, 2, 3, 4. Now the last carbon atom this side, so it has one bond already with this carbon atom, so it needs 3 more. So 1, 2, 3. So 1, 2, 3, 4. So this is how we will form the structure of isobutane. Basically, we have to take one carbon less, and in the second group, in the second carbon, there will be methyl group as substituent. Now we will take one more example of chain isomerism. So we will take the example of C5H12. So C5H12 has 3 isomers. So in this, one isomer will be straight chain, that is N-Pentane, whereas the others will be branched, that is Isopentane, and Neopentane will be branched chain. Now we will see how to draw the structure of N-Pentane. So pent means 5. So we will draw 5 carbon atoms and N is single bond. So 5 carbon atoms of single bond, that is 1, 2, 3, 4 and 5. Now we will satisfy the valency of carbon. So this carbon atom has a single bond with this carbon atom, so it needs 3 more. So we'll draw 3 hydrogen here. 1, 2, 3, 4. Now same thing we will do here, as this carbon atom has one single bond with the other, so it needs 3 more. So 1, 2, 3. So 1, 2, 3, 4. Done. Now the second one has already 2 bonds here, one with this carbon atom and one with this carbon atom, so it needs 2 more. So 1 and 2. Same thing with the third one. It has already 2 bonds here, one this side, one this side, so it needs 2 more. 1, 2, 3, 4. 1, 2, 3, 4, done. Now this carbon atom, same thing again, it has 2 bonds already here, one this side, one this side. 1, 2, 3, 4. Done. Now you can see there are 5 carbon atoms here, 1, 2, 3, 4, 5, and there will be 12 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So by counting you can vary 5 also. So this is C5H12 N-Pentane. Now we have to draw isopentane. So whenever this iso is there, so we have to draw one less carbon, and in the second carbon there will be methyl group as substituent. So pent means 5, so we will draw 4 carbon atoms here of single bond, that is as it is N. So 1, 2, 3, 4. Okay, and now we will on the second carbon atom we will put methyl group as substituent. Now we will satisfy the valency of carbon. So this has one bond with this carbon atom, so it needs 3 more. So 1, 2, 3 and 4. 1, 2, 3, 4. Done. Now the second carbon atom has one bond here, one bond here, and one bond here. So 3 bond it has, so it needs 1 more. 1, 2, 3, 4. Now third one has one bond here and one bond here. It has 2 bonds. It needs 2 more. So 1 and 2. Done. Now the last one, it has one bond here and it needs 3 more. So 1, 2, 3, and this will be the fourth one. So this is how the isopentane structure is made. Now if we have to draw neopentane, so here the carbon atoms will be linked. I'll tell you how. So again pent is 5, so what we'll do, we'll draw one carbon atom in the middle and the rest 4 will surround it like this. Okay, now we need to satisfy the valency of carbon. So H3 here, H3 here, H3 here, H3 here. So if you want, you can write like single like this also, like one single hydrogen, one single hydrogen, one single hydrogen, or you can write like H3 also, because here also it is 3 and here also it is 3. So one bond here and then it has 3 here also, so that is 4. So same way here, it has one bond here, one bond here, and one bond here, and one bond here. So 4 satisfied. And for this carbon atom, it already has one bond here and it needs 3 more. So I have written H3 here, so it is satisfied. Same thing with this. It has already one bond here and it needs 3 more. So I have written H3 and 1 plus 3 is 4, satisfied. Same thing for this one also. Now we will take one more example of chain isomerism, that is C6H14. So this has 5 isomers, N-hexane, isohexane, one more isohexane, neohexane, and one more neohexane. Let's see. So if we have to draw the structure of N-hexane, so hex means 6. So we will draw 6 carbon atoms and N means single bond. 1, 2, 3, 4, 5, 6. Now we will satisfy the valency of carbon here. So this needs 3, as this already has one bond here, so it needs 3 more. So 1, 2, 3. Now this carbon atom, it has one bond here and one bond here, so it needs 3 more. So 2 more. So 1, 2, 3, 4. Done. Now this carbon atom, it already has one bond here and one bond here, so it needs 2 more. So 1 and 2. Same way here, it already has one bond here and one bond here, so it needs 2 more. 1 and 2. And same thing it is here, it already has one bond here and one bond here, that is 2, and it needs 2 more. 1, 2. This one has one bond here and it needs 3 more, so we will write hydrogen. Done. Now you can count, as there will be 6 carbon atoms and 12 hydrogen atoms. If you count, you will get it. Now isohexane. So in iso we have to take one carbon less, and in the second carbon we will put methyl group as substituent. So here it is hex, so we will take 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Done. And in the second carbon we will put methyl group as substituent. So you can take second from this side also and this side also. 1, 2, 3, 4, 5, like that also you can do, or 1, 2, 3, 4, 5. So I'll take from this side and I'll put methyl group here. Next we have to satisfy the valency of carbon. So this has one bond here, so it needs 3 more. So 1, 2, 3. Done. This one, it has one bond here, one bond here, and one bond here, so it needs 1 more. Done. Now this one, it has one bond this side and one bond this side, it needs 2 more. 1 and 2. Done. Now this one, it has one bond here, one bond here, it needs 2 more. 1, 2. Done. And this one, it already has one bond here, it needs 3 more. So 1, 2, 3. Done. This is how isohexane of C6H14 is made. Now we have to do the numbering. Also numbering meaning 1, 2, 3, 4, 5. This is the numbering. Now I could even do the numbering from this side also, but why did I do from this side? Because the methyl group is this side, the substituent is this side, and the substituent should be at the least number of the carbon. So if I would do it from this side, it would come as 4. It would come as 4, which is more. we will do from this side because it is coming as 2. Now we have to draw one more structure of isohexane. So what we will do? We will do the same thing as we will draw 5 structure of 5 carbon. 5, 1, 2, 3, 4, 5, done. Now we will change the position of the methyl group. So it was here, we will just put it in the next one. Now we will satisfy the valency of carbon. So this has one bond here, 1, 2, 3. Now this has one bond here and one bond here, so it needs 2 more, 1, 2. This has one bond here, one bond here, one bond here, so we go like that. This has one bond here and one bond this side, so it needs 2 more, done. This has one bond here, it needs 3, so 1, 2, 3, done. Now you guys may be confused that why I didn't put this methyl group this side, because if we count from this side and do the numbering, second will come here and we should put the methyl group at the second carbon. I'll tell you why. Now before we had done the numbering from this side, right? 1, 2, 3, 4, 5. So here also we will do the numbering from this side also, or this side only, 1, 2, 3, 4 and 5. And now if I had to put methyl group here, it would come as 4, but now it is in 3, which is the less number, so that's why we will put it here. If we have to name this structure, this one, so how we will name it? So first we have to see that on which the substituent is there. So on the third carbon here the substituent is there, so we will write 3, then we will put a dash. What substituent is there? Methyl. So we will write methyl. And how many carbon atoms are there in total? 5. 1, 2, 3, 4, 5. So pent. We will write pent. And there is single bond, that is N. So we will write pentane. Done. So this is how we do the naming. If we had to name this one, so the substituent was in the second carbon, so we would write 2. Which substituent? We have to put a dash. Then what substituent was there? Methyl. So we'll write methyl. And how many carbon atoms were there? 5 carbon atoms. So we'll write pent, and it was single bond, so N. This is how we do the naming. Now we have to draw for neohexane. So here the carbon atoms are linked, so we will draw one carbon atom in like this in the middle and surround it like this. But we need 6 carbon atoms, so anywhere we can draw the 6th carbon. Okay, now 6 carbon atoms done. Now we have to satisfy the valency of carbon. So here one bond is already there, it needs 3 more. Done. Now here also same thing, it has one bond here already, it needs 3 more. This one, the middle carbon, it is already satisfied because it has 1 here, 1 here, 1 here, 1 here, 4. 1, 2, 3, 4, done. Now this one, it has 1 carbon atom this side, 1 carbon atom this side, so it needs 2 more. H. Done. Now we have to draw one more structure for neohexane. Before drawing one more structure for neohexane, can you see these 2 carbon atoms are not satisfied? Here they have only 1 bond, so we will write H3 here and H3 here. Satisfied? Okay. Now we will draw one more structure for neohexane. Here we will only draw 4 carbon atoms. 1, 2, 3, 4. Okay. And on the second and third one, we will put methyl group as substituent. And now we will satisfy the valence of carbon. So it has 1 bond here. It needs 3 more. 1, 2, 3. It has 1 bond here. It needs 3 more. 1, 2, 3. This one, it has one bond here, one bond here, one bond here. It needs one more. Done. This one, it has one bond here, one bond here, one bond here. It needs one more. So done. Now we have to name this structure. How we will name it? So here we have to see on which carbon the substituent is there. So here the substituent is there on the second and third. So we will write 2, 3 dash, where what substituent is there? Methyl, but there are 2 methyl. So we will write dimethyl. Di meaning 2, so dimethyl. And how many carbon atoms are there? 4. So we will write bute meaning 4, and it is single bond, so butane. Now we have to name this structure. So the substituent, where it is there? CH3 is the substituent. So that is methyl. So it is on the second carbon atom, but there are 2. So we will write 2, 2 dash dimethyl, because there are 2 methyl, and butane. So this is how we draw the structures of neohexane and name them. I hope you like this video. Thanks for watching.